ladies and gentlemen, when I'm graphing a logarithmic equation, there's a couple things I want to do. The first thing is I want to write out the general form for our transformations and determine the transformations. So therefore, I'll write y equals a times log base b of x minus h plus k. Therefore, in this problem, I can see there's a reflection over the x-axis, and there is a shift 2 units up. Yes? All right. OK. I wonder why that didn't work. OK. I see. Oh, that's weird. OK. So now what we need to do is I'm going to graph two different things. First thing, I'm going to graph the parent graph. And I like applying transformations because graphing the parent graph is pretty basic on this point that we can simply just graph So what we can simply do is when we're graphing them, the parent graph is what I already showed you guys, right? And I like going with the parent graph because I remember that my asymptote, the asymptote of this equation is going to be at x equals 0. The domain is going to be from 0 to infinity. And the range is going to be from negative infinity to infinity. All right? So there, now we've graphed the parent function. This is where the parent function, this is with no transformations. All right? Now what I'd like to do is, we see there's a couple transformations. One transformation is we have a negative, and then we have a and then we have a plus 2. Yes? All right. So another thing we could do, excuse me, ooh, wow, is also to determine another point. Right now, we only know what one point is. All right? And if you guys remember, what I wrote you guys down last time is we can always determine the remaining amount of points. So if I wanted to find another point on this graph to verify that I have it, I already know that 1 is 0. But what if I wanted to figure out another point that I could plug in? And one thing when you're doing that is you don't need to worry about the transformations. Just take the equation y equals log base 3 of x. Forget about the negative and the plus 2. If you just want to find 2 points from that parent graph, just use it without the transformations, but include the dilations. So therefore, if I wanted to find another point, I can pick any points I want. I would probably pick 9. And the reason being is because if I say y equals log base 3 of 9, rewrite that in logarithmic exponential form, that's 3 to the y equals 9. So therefore, we know that y has to be 2. So therefore, if you want to actually graph what exactly this line looks like, if that's point 1, I also have a point at 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2. This graph actually curves much sharper than my little sketch. OK? OK. So now what I want to do is now we need to go back through the reflection. So we said we have a reflection over the x-axis. So let's graph what it's going to look like. So right now, I have 2 coordinate points. I have a coordinate point at 1, 0. And I have a coordinate point at 9, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I have a coordinate point at 1, 0, and I reflect over the y-axis, does anything change? If I take this graph and I reflect it, is my x-intercept still the same? Yes. But if I have my point 9, 2, and I take this graph and reflect it over, and now instead of going over 9 up 2, now I'm going to go over 9 down 2. All right? So then what you guys can see, though, is now, instead of having an equation that looks something like this, I'm now going to have an equation that's going to go down, right? But then we also need to shift the graph 2 units up. So if here's now my transferred graph, I now need to shift them up 2 units. Shift up 2 units. To right there. OK? Now let's go and determine what we have. So now my graph, you can see actually crosses here, but we're going to show you an algebraic method. So let's go and take a look at my asymptote. Remember, my asymptote is vertical at x equals 0. Did that asymptote move left or right at all? No. It's a vertical line. It didn't shift left or right. So therefore, your asymptote is still x equals 0. My domain. Domain, still, again, I didn't shift my asymptote, so my domain is going to be the same, 0 to infinity. And my range, this is where it gets a little tricky. Because before, my range, actually, no, my range is still, this is going to keep on increasing, and this is going to keep on decreasing. So my range is going to be from negative infinity to infinity. Now, I'm going to show you guys the algebraic method, but this is pretty obvious because you also, one of the also interesting things we're asking is to find the x-intercept. Well, ladies and gentlemen, this problem is easy because when we shifted it, we actually shifted it to an x-intercept, which is awesome. However, what about if you don't have that ability? What if you actually need to figure it out algebraically? So let's go back and see how can we go ahead and possibly do that. I'll try to make it as painless as possible. So if I gave you the equation 3x plus 2y equals 12, and I say, hey, find the x-intercept, now you'd have to do plug in what for what? What for 0? If I said find the x-intercept, then for what? Put 0 in for what? Y. For y, right? It's very easy. Then you solve for x, right? Yes? OK. So ladies and gentlemen, if I give you a crazy equation like this, y equals negative log base 3 of x plus 2, if I give you an equation like this and I say, find the x-intercept, what do you think you're going to plug in for what? You're going to want to plug in a 0 in for the y. How am I going to solve this? Well, to solve logarithmic equations, what we're going to have to do is isolate our log. So therefore, I want to get the log all by itself. So now I have 2 equals log base 3 of x. And Ryan, do you know what we could do from here? What have we practiced when we have something that's in this form? What have we talked about so far in this form? We can convert it to anybody know? We can convert this to German exponential form, right? That's what I was doing those 2 problems for you so many times. So converting this exponential form, I've been doing way too many of these problems. 3 squared equals x. 9 equals x, which we already knew that. I mean, this one was easy. It was we already graphed it with an x-intercept. However, a lot of times you're going to have problems that it's not going to be so apparent. OK? And that's it.